If you get to the situation where you've got a bunch of 3-year-olds that need to have life-saving therapeutic rations, it's hard to bring them back. And on the other hand, if you could have gotten that kid a few dollars worth of food in the week before that, that can make a huge difference.
Hello, everyone. Welcome to this episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet and on the people here at EROS and across the world who use remote sensing to monitor and study the health and well-being of Earth. I'm your host, Steve Young. Today's guest is Chris Funk, a research geographer who works for us at the Earth Resources Observation and Science Center. He is also the research director of the Climate Hazard Center at the University of California in Santa Barbara, which along with EROS is involved in monitoring, modeling, and predicting food insecurity among drought-afflicted people across the planet. Welcome, Chris.
Thanks for having me.
How serious is food insecurity on our planet?
It's a much bigger problem than you would think, and it's actually been getting quite a bit bigger just in the last few years. Between 2015 and 2018, the number of really food insecure people grew by about 80%. And is currently about 85 million people. And if 85 million people were to hold hands and circle the globe, they'd go around 13 times. And another way of thinking about it is it's about 1 out of every 100 people on the planet. So despite our incredible wealth and the fact that as a whole the planet is getting a lot wealthier, there are still a lot of people left behind who are facing severe food insecurity.
Do we have an understanding of why it's getting worse?
First of all, it's obviously related to poverty. If you have poor households in a lot of the countries that are facing food insecurity, they may be making, $70, $150, $200 a year and spending 70% of their income on food. And so when food prices spike, they often just have to simply go without. So obviously poverty is a big factor. Also, conflict is a major driver. So we're seeing, severe conflicts in eastern Nigeria, South Sudan, Yemen. But surprisingly, droughts continue to be a major source and driver of food insecurity as well.
You and EROS are part of this initiative of the U.S. Agency for International Development's Famine Early Warning Systems Network. Tell me what FuseNet does.
FuseNet tries to identify essentially where are the people who are facing or likely to face in the near future really severe conditions, such that if they don't get humanitarian assistance, they could die due to famine.
You are in the business with FuseNet of projecting or predicting where drought and famine may occur, and you do that several weeks, months in advance. How are you able to do that? Can you kind of walk us through how you do that?
Sure. It involves using a suite of different information sources appropriately at different parts of the season. Landsat is an excellent tool to use at the end of a season. So, you know that it's been bad and you want to zoom in from space and really look at this dry area in detail and really assess how bad is. So Landsat's really good for that. Then, if we want to back up in time a little bit, we're developing ways to, I have actually implemented this, ways to combine weather forecast information with satellite observed precipitation. And in the middle of a season, this is like a super effective tool to look at mid-season droughts. And so we can say, if we're talking about a cornfield here near Sioux Falls, we can say, it had a poor start to the season. It was dry all the way through July, and August is forecast to be dry too. So we're almost certain it's going to be bad. And so we're not quite as sure as we were with the Landsat, but we're pretty sure now that it's going to be bad. And then we can back up a little bit more, and we may talk about the situation in kind of mid-July, where we can say, our satellite observations have shown us that it's been a really wet spring. Maybe that's going to affect planting. And then we can back up even further to before the season, where we might want to use our climate information to say, we're seeing these El Nino-like conditions. Maybe that's related to above normal rains over the Great Plains. And so There's no one information source that's the best, but the art is really putting the pieces together as effectively as you can.
It sounds like FuseNet relies in part on satellite systems like Landsat. How can something flying 400 miles above the Earth tell you about crop conditions across the planet?
Really, just the same way if you're looking out of your car and like driving out here this morning, looking out of my car, I noticed that there were a lot of fields that didn't have corn in them, right? Which I guess is because of the rains have been exceptionally wet this year. And satellites like Landsat give us this an amazing ability to, literally see like we would with our eyes almost, the land surface of the Earth. And if you're skillful at working with that data and know where and when to look, that's part of the secret, you can almost always tell when there's been a really major disruption in crop growing activity.
And how do you verify that those Landsats are accurately seeing what's happening?
Since 2011, the FuseNet team has published like over 100 papers and reports. And this is where you put on your science hat and you do your comparison to crop yield statistics or different kind of data sets. And there's a lot of work that we do like that so that our early warning information data sets are really credible and accurate. And that's the process of science.
Is this a big guessing game?
Well, you're wrong sometimes, but the value of this kind of integrated drought early warning system is that one of these things may fail, but not all of them will. So maybe your climate forecast was off, but then your satellite precipitations should see the drought. And if your satellite precipitation doesn't see the drought, for sure you'll catch it with Landsat, right? So that's the whole point of using a kind of convergence of evidence approach.
What happens if you're right? I mean, do you save lives?
We save lives. I really can say confidently that the information that we provide is used by others to send life-saving aid to people, and some of whom would perhaps have died without our help.
Who sends that? You send the information to who? And
well, most directly, Food for Peace. I don't have the exact number, but the budget for humanitarian assistance, I think, is something on the order of like $4 billion a year. It's our job, though, to make sure that that money is spent as effectively and efficiently as possible.
And how do you do that?
Well, being early is a big part of the thing. It's really expensive, for example, if you get to the situation where you've got a bunch of, little kids, 3-year-olds, that need to have life-saving therapeutic rations. You've seen the terrible pictures, right? I mean, you get to a kid at that stage, it's hard to bring them back, and there's often lifelong debilitating effects from that. On the other hand, if you could have gotten that kid a few dollars worth of food in the week before that, that can make a huge difference.
So the food that is going to them through Food for Peace, is it going to them early in the projected drought or famine stage? Is it going to them in the middle? How do we know when to interject ourselves into that equation?
I'm really not an expert at that, but there are some case studies that I've looked at for my own interest. In early 2017, this Landsat information was used to really highlight the severity of the conditions in Somalia and trigger international assistance. And so I have dug into the numbers of the aid going into Somalia in that year, and it was something like in December of 2016, food aid for 500,000 people arrived. That number doubled in January of 2017, and I think doubled again in February, so that by March and April, food aid for millions of Ethiopians was already arriving. And then in April of that year, we saw an almost complete failure of the rainy season. And the effects of that typically are felt strongest just after the rainy season. And, at that point, there was already a lot of food aid arriving in the country. And so ideally, that's when you would like to have it happen early. So there's a big difference in food aid arriving in Somalia in, say, February or March or April as the season is failing, than arriving in September when people have been hungry for 6 months.
And having that food aid there available before September keeps markets stable and prices low, and all of that comes into play here.
Exactly.
I understand there's been a fairly significant improvement in FuseNet's ability to do what it does from 2011 to today. How so?
Yeah, there's been a pretty amazing amount of work that's been done since then. We've published more than 100 papers and reports looking at different aspects of the science of early warning. Here at EROS, there's been incredible improvements in the drought monitoring portals, and we have new tools like the Early Warning Explorer that let people access the data. We have new remote sensing data sets like the EMODIS Normalized Difference Vegetation Index data set and the actual evapotranspiration anomalies that are produced here. With UC Santa Barbara, we've produced this climate hazards infrared precipitation with stations and climate hazards infrared temperature with stations data sets. We have these really exciting new approaches for integrating these satellite observations with weather forecasts. And finally, we have a really systematic food security outlook process where we get together every month with the partners from NOAA and NASA and basically try to come up with really well-organized and accurate descriptions of the climate and drought conditions in different countries and kind of how they're going to evolve in the near future that we give to the folks in Washington, D.C. to try to identify the humanitarian aid emergencies.
Can FuseNet get better?
Absolutely. Yeah, there's a lot more that we can do. There's exciting opportunities in terms of how we can use some of these really high resolution data sets better and better. There are lots of challenges in how we can link together the pieces in terms of satellite observations and weather and climate forecasts. There's lots of challenges in terms of how we can better use information about conflict, poverty, household income, the kind of human side of the equation. All that could make huge strides in the near future.
We've been talking to Chris Funk, a research geographer who works at EROS. He's also the research director of the Climate Hazard Center at the University of California in Santa Barbara. It's been a fascinating conversation, Chris. Thank you.
Thanks a lot. This has been great.
We hope you come back for the next episode of Eyes on Earth. This podcast is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.